next function here, we're looking at f of x too big. Give me a sec. Okay, f of x is equal to -3 x minus 2 and then plus 3. Okay. So again, before we begin with our vertical asymptotes or asymptotes in general, let's start with transformations. Okay, we have 4 different transformations happening on this function. So let's begin with transformations in the correct order, right? So I know that this represents my h, okay? If h is, in this case, if it says -2, then I'm going in the opposite direction. So I have a horizontal shift 2 units right. Okay. Then I want to look at my a value. In this case, my a value is 3. Okay, since 3 is larger than 1, then I'm going to have a vertical stretch by a factor of 3. And then also, after vertical stretch or compress, then we look for any reflections. In this case, I have a reflection. This negative indicates that it is a reflection across the x-axis. Okay, if it was a y-axis reflection, okay, I'm going to show you where it would be. It would be right in front of the x down here in the denominator. Okay, but because it's not, right, or it's right in front of the numerator, sometimes you might see it this way as well, where you'll have a negative out front and then the fraction. Okay, it doesn't clearly, in this case, notice how it doesn't really clearly indicate whether it's in front of the 3 or in front of the x. Okay, if it is a neutral state, right, if it's in a neutral spot right in between, in the middle between 3 and x, then what you're going to do is you're going to assign that negative to the numerator. Okay, and that's usually how you'll see it typed out on like your homework or on a quiz. You'll see the negative in front. That means that the negative belongs to the 3. So you're looking at a scenario like this. Okay, so because the negative is out in front and not in front of the x, okay, then that's a reflection across the reflection across the x-axis. Okay, so what we have here is a reflection across the x-axis. Okay. All right, and then finally we can then say that we have a vertical shift, right? Here's my k, so I have a vertical shift 3 units up. Okay. All right, so let's go ahead, let's erase this piece for now. And let's go ahead and start looking for our asymptotes. Okay, so we're going to look for vertical asymptote first. So I'm looking for VA. So I'm going to set the entire denominator equal to 0. So I get x minus 2 equals 0. Therefore, at x equals 2, I have a vertical asymptote there. Right? That makes sense. That follows our transformation. Right? We were going to shift this 2 units to the right. So now we have a vertical asymptote at 2. Okay. Then for horizontal asymptote, HA, then now we can look at K, right? K is 3, so we have a horizontal asymptote at 3. And that also makes sense because we were going to shift this 3 units up, okay? All right. We can then state domain. Right now we have domain. We know that the one number that we don't want it to be is 2, because if you were to take 2 and plug it in for x, what happens in the denominator? You get 2 minus 2, which equals 0, so now you have a 0 in the denominator. Okay, so plugging in 2 is going to give you undefined. So for domain, we can then say we want all the values of x, all the numbers, all real numbers, such that x does not equal 2. Okay, and then for our range, we can say that the set of y values such that y does not equal 3. Okay, all right. So let's start with that. Let's go ahead and move over to the right side. Let's start building the xy plane with the asymptotes. Okay, so let's go here. All right. We said we had a vertical asymptote at 2. So at 2, 1, 2. Let's go ahead and graph the asymptote here. So VA at x equals 2, and then a horizontal asymptote at y equals 3. Okay, so let's go there. 1, 2, 3. Horizontal asymptote this way. Okay, so HA at y equals 3. Alright, so now let's go ahead and fill in our table so that we have some points. Okay, and notice that we're also we had a reflection across the x-axis. So the curves are not going to be where you expect them. Okay, just imagine, right? Go back to this one. Pretend that these two functions got reflected across the x-axis, right? Would they still be here and here, right? What would happen to them instead, right? Instead, right, you would indicate, if this would have been reflected over the y-axis, they would have been here and here, right? They kind of flip-flop position. Okay, so I'm just showing you that to kind of get you an idea of where these two curves are probably going to be. All right. Okay, so let's go ahead and start with the t-table here. Let's go with x and y. Okay, I know that the number that causes issues is 2, so I'm going to put 2 in the middle of this table. So I'm going to leave space for 3 values, 1, 2, 3. Plug in 2. 2 is what gives me undefined. So I know I need 3 values to the left of 2, so let's go with 1, 0, and -1. And then on the other side of 2, we have 3, 4, and 5. Okay, and our function here is -3 all over x minus 2 plus 3. Okay, so let's go ahead and try to clean this up. All right, so we have -3 all over -1 minus 2, and then plus 3. That's going to give us -3 minus all over -3 plus 3. Well, -3 divided by -3 is 1, plus 3 equals 4. Okay, now we got -3 all over 0 minus 2 plus 3, which is going to give us -3 over -2 plus 3. So that's the same as 3 over 2 plus 3, which is also equal to 9 over 2. Okay, that is also the same thing as 4.5. Okay, or 4.5. Alright, let's plug in 1. So -3 all over 1 minus 2 plus 3 equal to -3 all over -1 plus 3. This simplifies to be 3 plus 3, which ends up being 6. Okay, let's move on. Now we have -3 all over. That's going to be 3 minus 2 plus 3. So down here, we're going to get -3 all over 1 plus 3. So that's actually -3 plus 3 equal to 0. Okay, let's keep going. -3 all over 4 minus 2 plus 3. That's -3 over 2 plus 3. So essentially, that's going to be 3 over 2, which is the same thing as 1.5. And finally, we plug in 5. So -3 all over 5 minus 2 plus 3 equals. Okay, so we'll get -3 all over 3 plus 3. Well, -3 over 3 is -1 plus 3, so we get 2. Okay. All right, so now let's move on to the other side. Let's start plotting these points. Okay, so I have -1, comma 4, 0, comma 4.5, 1, comma 6. Okay, so let's go -1, and then up 4, 1. So let's see, 1 to the left, and then 1, 2, 3, 4. That's a point right there. Then we have 0 up 4, 1, 2, 3, 4.5. Okay, so that's right here. And then the last one is going to be 1, and then up 1, 2, 3, 4, 5, 6. Okay, so there's a point right there. All right. So I'm going to extend my vertical asymptote a little bit because I want my graph is actually going to come, it's going to grow pretty tall. All right, so now I can then say, all right, connecting between those 3 points, I have a curve that does something like this. Okay. And then now let's plot on the other side. So now I have the point 3, 0. I have 4, 1.5, and then 5, 2. Okay, so 3 to the right, and then at 0. Then we have 4, and then 1.5, so here, and then 5, and then up 2. Okay, so then I can see the curve is doing something like that. Okay, and there's a rational function, right? So notice what the reflection across the x-axis did, right? I can compare these two, right? The curve that was down here, right, let me highlight it. The one that was down here, right? The reflection causes it to move up here. And then the same thing for this one that was up here now gets shifted, reflected, so now it looks something like this. Okay, and that's basically what we have in the example below. Okay, so that's what the reflection across the x-axis will do. Okay, it'll kind of flip-flop the two curves, right, from where they were before. All right. So now I'm going to leave this last one for you guys to do on your own. Okay. You can go ahead and flip the page and then do this example on the next one if you're out of space. Okay, so let me go ahead and draw another line, and then I will give you the example, and then I will leave it for you guys to try it on your own. Okay. All right. Okay, so go ahead and try this one. F of x is equal to 2 all over negative x plus 2 and then minus 4. Okay. So I would like for you to first describe the transformations. Two, find the horizontal and vertical asymptotes. 3, find the domain and range. And then 4, make a table, and 5, graph. Okay. So right now, I would like for you guys to pause the video, okay? Work on it on your own. If you feel like you get to a point where you're stuck, then keep playing the video and kind of walk yourself through it until you feel like you're at a point where you're comfortable to keep trying it on your own. Okay, so try not to just follow the video along and watch me do it. I want you to try it, okay, so that you have a feel of, right, like how to get to that final spot. All right, so from here, right, assuming that you've already worked on it on your own for some time, you're either watching it now because you got stuck or because you finished and you want to make sure that you did this correctly. Okay, so I'm going to go through and I'll finish it up. All right, so the first transformation that occurs here is the horizontal shift 2 units left. Okay, so let me erase some of this. Okay, so first we get horizontal shift, 2 units left. Okay, then I see that we have a value of 2 here, right? That's my A value. So that tells me I have a vertical stretch by a factor of 2. Then I notice that I have a negative here in front of x, right? That's kind of obvious. That negative is directly in front of the x. That's telling me that I have a reflection across the y-axis. Okay, so we can say reflection across y-axis. And then finally, I have a negative 4 out here. So then we can say that we have a vertical shift 4 units down. Okay. All right. So that's transformations. Now let's take a look at finding the horizontal and vertical asymptotes. Okay. So if I want vertical asymptote, I'm going to set my denominator, the entire denominator, equal to 0. Okay. So let me erase this highlight real quick. I know there was a negative there. I want to take the entire denominator, set that equal to 0. Okay, so here's what I have. Negative x plus 2 equals 0. Okay, if I add x to both sides, okay, I'm doing that to kind of save myself a step. I get x or 2 equals x, which is the same thing as x equals 2. Right, so that tells me I have a vertical asymptote at x equals 2. And if I look for a horizontal asymptote, then I just look for k. Right, k in this case is negative 4, so then y is equal to negative 4. All right. So now step 3, let's look for or identify the domain and range. Right, so I can say here that my domain is going to be the set of x, all x values, such that x does not equal 2. Okay, because if I took 2 and I plugged it in here, I would end up with negative 2 plus 2, which equals 0, and that's what I don't want in my denominator. Okay, and then for range, then we can say it's the set of y values such that y is not equal to negative 4. Okay, we don't want it to equal negative 4. All right, so we're done with domain. I'm gonna go ahead and make the table first. Actually, no, let's keep doing what we've been doing. So let's go over and draw the XY axis. All right, so we have vertical asymptote at x equals 2, so at 2, vertical asymptote x equals 2. And then we have a horizontal asymptote at negative 4, so 1, 2, 3, 4, right here. There's our HA, y equals negative 4. Okay. All right, so now let's go back to the table. Let's make an XY table here. And let's calculate some values. Okay, so I know my function here is 2 over negative x plus 2 and then minus 4. All right. So since 2 is what causes the problem, it's what causes the undefined, then let's skip 3 spaces, 1, 2, 3. Let's use 2. We know when we plug in 2, we get undefined. So now I can find 3 values less than 2. Let's go with 1, 0, and negative 1. And then 3 values bigger than 2, so 3, 4, and 5. All right. So let's get in here and let's do some work. So I take 2 all over. Notice how there's already a negative there in front of x. So there's a negative in front, and then whatever I plug in for x, in this case it's negative 1, that goes in for x. So now I need to put parentheses there, negative 1, and then plus 2, then minus 4. Okay, when I clean all of that up, I'm going to get negative 10 over 3, which is the same as negative 3.33. Okay, and it keeps repeating. All right, now let's plug in 0. So 2, negative 0. Again, there's no negative 0. It's just 0 plus 2 minus 4. When I clean all of that up, okay, that just becomes 2 over 2 minus 4, which is 1 minus 4, which gives us negative 3. Okay, 2 over negative 1 plus 2 minus 4. That's the same as 2 over 1 minus 4. So that's 2 minus 4, which is negative 2. Okay. Now the other side, I have 2 all over negative 3 plus 2 minus 4. That's going to be 2 over negative 1 minus 4, which gives us negative 2 minus 4 equal to negative 6. Keep going. 2 over negative 4 plus 2 minus 4. That's equal to 2 all over 2 minus 4. So 1 minus 4, negative. Wait a minute, sorry, made a mistake here. 2 all over negative 4, so that's going to be 2 over negative 2, sorry. So that's negative 1. So negative 1 minus 4 is negative 5. And then we plug in 5, so 2 all over negative 5 plus 2 minus 4. That equals 2 all over negative 3 minus 4, which when we clean all that up is negative 14 over 3, which is approximately equal to negative 4.66, and it repeats. Okay, all right, so that's good enough. Let's clean that up. That should be a 10. Okay, all right, so let's start plotting some of these points. I have negative 1, negative 1, so 1 to the left, and then down 1, 2, 3, and then 0.33, so about a third of the way down, about right here. Then at 0, I'm at negative 3, and then at 1, I'm at negative 2. Okay, so I can see that the curve would be doing something like this. Alright, now let's look to the other side. At 3, so 1, 2, 3, I'm at negative 6. 1, 2, 3, 4, 5, 6. Point right there. Then we go to 4, 1, 2, 3, 4, down 1, 2, 3, 4, 5. And then the last point would be 5, 1, 2, 3, 4, 5, down 1, 2, 3, 4.66. Okay, so it's somewhere right around here. Okay, so we can start to see the outline of that curve. And there it is. Okay, so that's our function for 2 over negative x plus 2 minus 4. Okay. All right. So that's how to graph, right? How to find enough values to help you graph that using the asymptotes as a guide. What I want to do next now is take a look at how to find the x and y intercepts, right? So if you have your foldable, take that out. I want to show you how to what happened? Give me a second. All right. So I wanna find the x-intercepts here for this function. I'm having some issues. All right. Let's see. Can I draw on this? All right. There it is. Okay. So I'm gonna show you how to do this one, and then I'll leave the rest for you, the other example in the foldable, to do on your own. Okay, so just like always, right, we're looking to solve for x-intercepts. What we're trying to do is get the f of x equal to 0, right? So we're going to set it equal to 0, so we get 0 equals -1 all over x minus 3 minus 4. All right. The idea is you want to get x by itself. Okay, so you want to treat the fraction, right, as one piece. Okay, so let me highlight it. What we want to get by itself is all of this. Okay, which means -4 has got to go. We got to move it to the other side. All right, so let's do that first. Let's add 4. All right, so we have 4 equals -1 all over x minus 3. All right, we want to get x into the numerator. Okay, x minus 3 is an entire piece. Okay, so put parentheses around it because you can't break up the 3 from the x, right? It has to move together. Okay, now from here, what we're going to do is we're going to use cross multiplication to simplify this a little bit. All right, so notice that 4 doesn't have a denominator, but I can give it one. I can give it a 1. So we can cross multiply here. I'm going to multiply -1 times +1, and then I'm going to multiply 4 times the entire quantity of x minus 3. When I do that, that's going to give me -1 times 1 gives us -1, and then when I multiply across the other way, it's going to be 4 times x minus 3. Okay, so from here now I can distribute my 4. I get -1 is equal to 4x minus 12. Right, I'm going to keep going up here. -1 equals 4x minus 12. I can add 12 to both sides. So I get 11 is equal to 4x. Divide both sides by 4. X is equal to 11 over 4. Right, so the function is going to cross the x-axis at 11 over 4, which is approximately 3 3/4. Right, something like that. Or about 3.75. Okay, but for you, just put 11 over 4 here in that box. Okay. All right. If then I want to find the y-intercept, same idea as we've always done. We're going to set x equal to 0. So I'm going to have f of 0 equal to -1 all over 0 minus 3 and then minus 4. So when I clean this up, this gives me -1 over -3 minus 4, which is the same thing as 1/3 minus 4 when the negatives cancel out. Okay, 1/3 minus 4, I can multiply top and bottom by 3 here. So I get 1 over 3 minus 12 over 3, which is the same as a -11 over 3. Okay, so I have a y-intercept at 0, comma, -11 over 3. All right. So to get an idea of where this is at, that's approximately about -3 2/3, which is about -3.66. Okay, -3. All right. So we can put those 2 points on the function, and then we can try to graph based on just like using the asymptotes and see if we can just create a quick sketch. Okay, so if I have an x-intercept at 3.75, then if I zoom in here, at 3, not quite at 4 yet, right around here, would be an x-intercept. Okay. A y-intercept would occur at 0, -3.66. So let's say somewhere around here. Okay. Then, right, using our vertical asymptote, I know that to get a vertical asymptote, I set the denominator equal to 0. So I have x minus 3 equals 0. So I have an asymptote at x equals 3. So at 3, I can draw a vertical line. Let me get a little bit more precise. And then a horizontal asymptote is going to occur at -4. Okay, at -4 because that's our y value. All right. Okay, so oops, -4. Sorry. Domain, right? We can use vertical asymptote to help us there. We're domain. Let me go back to green. We know that that's going to be all x values such that x does not equal 3, right? Because if we plugged in 3 here, we would get 3 minus 3. That gives us 0. So that's undefined. That's not what we want. Okay, so we have to exclude 3 from the domain. And then for the range, we're trying to exclude -4. Okay, that's the k value that we don't want. So y, all values of y such that y does not equal -4. Okay. So now, without having to use any other let me see, just double checking I didn't make a mistake here somewhere. That's 1/3 minus 4, so 1 minus would be -3 2/3. My x value, let's see, that becomes -1 times 1, -1, 4x minus 12 plus 12 is 11 divided by 4. That is going to be... Oh, wait a minute. I think I made a mistake here. Yes, okay. So 4 over 11 is not 3 3/4. It's actually 2. It's actually 2 3/4. So go back and fix that. Sorry. Okay, 4 goes into 11 2 whole times, and then there's 3 left over. So that's actually 2.75. Okay, so that makes sense because I was trying to see what I did wrong here. So in reality, I have an intercept at 2.75. So 1, 2.75 is somewhere around there. Okay. All right. So now I can see, right, that if I were going to have a curve that was bounded between these two lines, then it would have to be something like this. Okay. And I know that then the other curve has to be on the opposite side of this, right? So again, we're just doing a quick sketch. We're not going to use a t-table here. That means that then my curve on the other side has to be roughly something like that. Okay. So at least that's good enough for now, just in terms of graphing without a t-table, using only the intercepts and the asymptotes. Okay. All right. So try the other one on your own. I won't be showing the video on that one. I really want you to try it without going back and watching any video to support it. Okay. So from there, if you're done, then move on to your homework, which will be homework number 4. Once you're done with this video, try practicing. If you have any questions, just send them to me. You can send them on Schoology. You can send a picture of an example and ask if if you think you did something right or wrong. Okay, just let me know. All right, and hopefully I'll see you guys soon.